My name is Caroline Key, and I am doing Khan Academy problem 19.4 of electrochemistry. In this problem, you need to construct a voltaic cell for an experiment. You look on the shelf and you have a manganese electrode and a silver electrode, as well as soluble salts of both metals. Fully label the diagram below and calculate the value of E cell and delta G for the cell if you had A, 1.00 molar solutions of both salts, and B, 1.25 molar solutions of the manganese salt and 0.076 solution of the silver salt. So let's start off by labeling our diagram, which is below. On the left side is the anode, which is manganese, and then on the right side is cathode, which is silver. The silver is reducting and the manganese is oxidating. For our two salts in our salt bridge that we are using for this problem, we are using NaSO3 and Na2SO4. And as you can see, anode is negative and cathode is positive, and so the electrons will travel from the manganese to the silver. Now let's look at the half reactions. The half reaction of manganese is Mn solid reacting to become Mn2 plus aqueous plus 2 electrons. And then silver is Ag plus 1 electron reacting to become Ag solid. But since manganese has 2 electrons, we have to multiply silver by 2 to be able to cancel out the electrons. So like so. And then our full reaction that we get would be 2NO3 minus plus Mn solid plus 2Ag plus aqueous reacting to become Mn2 plus aqueous plus 2Ag solid plus SO4 2 minus. Now, the 2NO3 minus and the 2Ag plus make the silver salt, and the Mn2 plus and the SO4 2 minus make the manganese salt. For part A, we have to calculate the value of E cell and the delta G of both salts if they have a 1.00 molar solution. So for the E cell equation, we are going to use E cell equals E cathode minus E anode. The cathode is silver, and the anode is manganese. To find the values that we plug in, we have to look at a chart that are given to us in our notes that is also on a chart of the half reactions. So since we multiply silver by 2 over here, we also have to multiply silver by 2. So we have 2 times 1.99 minus negative 1.18, which gives us 5.16 volts, or 5.16 joules per coulomb. To find the delta G, we are going to use the equation delta G cell equals negative NF E cell. Now let's write down what we have. So N equals 2 moles electrons. F is a constant that is given, so it's 96,485 coulombs per mole electrons. And then the E cell is what we just calculated, which is 5.16 joules per coulomb. Now let's plug everything in. So we have delta G cell equals negative 2 moles electrons times 96,485 coulombs per mole electrons times 5.16 joules per coulomb. And our final value is negative 9.95880 joules. Now, for part B, since we are given 2 different molar amounts for their 2 different solutions for the salt solutions, we have to use a different equation, which is E cell equals E cell minus RT over NF log products over reactants, like so. The RT can be turned into 0.0592 and then over N with the log with products over reactants. Now let's plug in everything we have. So our E cell, which we calculated previously, was the 5.16 volts minus 0.0592 over 2 moles electrons times log products over reactant. So the product is the manganese salt, so 1.25 molar over the salt, which is 0.076 molar. And then our E cell that we calculate from this is 5.1124 joules or volts. Now, for our delta G, we use the exact same equation as up here. And so we have delta G cell equals negative 2 mole electron times 9.65 times 10 to the 4 joule per mole times 5.124 volts, or joules per coulomb, and then the delta G cell equals negative 988,932 joules. Thank you for listening to my problem.